Hello. Is it possible to have my slide? So this is for the Solidity devs out there. We've got a whole new tooling set for Solidity, for Solana. This allows you to take Solidity and compile it into native Solana contracts, and which should make it very fast and has a number of other advantages. So at this moment in time, if you want to write a smart contract for Solana, if you want to do a native one, you'd have to write it either in Rust or in C. I think C++ is also possible now. If you want to use Solidity, then you have to use an EVM layer in order to make that work. So this is a project where we don't use EVM. We take Solidity source code. You can compile it directly to BPF, smart contracts. So this is a completely new compiler, which is a completely new compiler which is written from scratch. I started this in 2018 on a rainy Sunday when I thought I can write my own one. I have a background in compilers. So I had been looking at the Ethereum Solidity compiler, and they don't use LLVM, and they have a handwritten parser. So I thought, by starting this project from scratch, we can do a number of new things. We can write it in Rust. We can use a Solidity grammar. And by using LLVM, we can do code gen for different chains and make it also very efficient. So we can generate very efficient code. However, if you want to compile to Solana natively, then there are going to be differences. There's lots of technical details, implementation details of Ethereum which become evident in the language, like gas, for example, which doesn't really exist in Solana. On Solana, you have a budget, and you have to execute within that budget. So you don't really have the concept of gas left. So if your source code uses gas left, then well, all of that just has to be taken out, or has to be replaced with something equivalent. Also, because we're not running on an EVM virtual machine, we're running on BPF, if there's an assembly statement in the Solidity source code, then that won't work either, because we don't have EVM instructions. So those sections will have to be rewritten. But we've posted up Uniswap, for example. Those changes are quite small, so the re-audit should also be quite small. I did bring Aha. No, wrong way. So apart from functionality which is different, because we have a whole new compiler, we can also add functionality. And this is a bit more difficult with the Ethereum compiler because that targets just the Ethereum chain. So we can do things like ED25519 signature verifications. We have a print function. So if you want to debug with your Solidity code, you can just use print, which makes life so much easier. You can even do string compares and string concatenations, and you can do string formatting. All of those things are not possible on Ethereum, and we can extend the language whatever way we see fit. So we want to be sensible about what we could possibly add to the language. Nope, I did it the wrong way again. We also have some more tooling. So because we've written Rust, we can use a whole bunch of Rust crates. There's a Rust crate for language servers. So we've implemented that, and so we have a language server, which means we also have a Visual Studio Code plugin, which gives you nice little hovers of types and so on, and gives you warnings and errors and squiggly lines. So it's nice for the development experience. It should also work in other IDEs. We have a new NPM library called @Solana Solidity, which allows you to deploy, call, and Solidity contracts, get events, get return values, etc. All of this requires Solana 181 because we needed to add some functionality to Solana to make this work. So just a simple example, very super basic contract, just to show what it would look like. So you have a flipper, then you compile it. So you run Solang with the source file. You say, I'm compiling for Solana. Then the output is you have a bundled SO. So that's a native Solana contract file. You have an Ethereum ABI file. And it also outputs a line saying the account data for this contract needs to be 17 bytes. So that's just useful information. So you can use the minimum amount of data for your contracts. So here's some JavaScript to make it work. So you connect, you read the ABI file, you read the SO file. This is just some stuff to do an airdrop for your local test program. So you load the program once. So the compiled program is loaded once. So unlike Ethereum, where each contract has an entire copy of the entire code, on Solana we have one contract which contains the code, and that can be reused many times. So if you want to deploy the same contract twice, you don't have to pay for it twice. You only pay once for the upload of the contract. So you have uploaded the code. You need an account to store the account state. So you generate a key pair. On the program you call deploy contract with some information about the contract, including the construction arguments, also the amount of space you want the account to have, which is 17 from the earlier slide. We probably need some sort of better metadata so that information is passed along automatically. And then you get a contract as a result, on which there's a functions interface where you can call the get function. So this get function is the same as too far away. The get function is the same as the get function here at the bottom. So this function is view. So here we can, because the function is view, we can do simulate, and then the function is simulated. So you don't need to pay for it. We have a new version of the library which does this automatically for you, so you don't even need to pass simulate. It's not quite published yet. We'll do that soon. You can also call the flip function on the flipper. And then when you get it, then the state has been flipped. So the await contract functions flip. That will do an actual transaction. So that's a very basic example. So a few more technical details. So in Solidity, a lot of the types are 256 bits. And in BPF, that's not the case. In BPF, registers are 64 bits, which means that the code gen for some instructions has to be a number of instructions. So if you add to uint 256, that's 4 instructions for 4 adds to make each 64 bits work. If you have a multiply, divide, or modulo or so, then it gets a bit more complicated. You have sort of big int kind of functions you need in order to make that work. But often the actual values involved aren't that large. So there's a code pass in Solang which tries to reduce the strength reduction on multiply, divide, etc. So here we have a loop from 0 to 10, multiplied by 100. The compiler knows that value can never exceed 64-bit, so it will just truncate the values and do a 64-bit multiply. So it could even derive. So this is what it can do currently. Maybe in the future what we can do is derive that the variable I could just be 64-bit, and even simplify the code even more. So there's a number of optimizations we can do. So this is not the only solution. There's also NeoVM, of course. So NeoVM offers very precise EVM compatibility. So you can take any contract which is written in any Solidity version, and it will just work. However, it has to simulate each EVM instruction. So that's just slower. Solana compiles native code, which means you just get faster code, and you also get access to native features. So like the print function, the program log, you can just print directly to that. With NeoVM, you don't have the functionality because it doesn't exist in Ethereum, so it's not an Ethereum compiler, so you're just not going to have it. So NeoVM certainly it's very useful, and for some use cases it might be a better solution. But here we're trying to do a Solidity dialect for Solana. So we're now at a point where all the built-ins, everything works. They all got unit tests. So now we're at a point where what we really want is people to start using it, and we want to help you. So if you're a Solidity dev, you have some contracts, please try it out, tell us what you think, tell you what can be improved, and we really want to make it work. So we're here to help. We need more functionality, we need more bridges to native things. So at the moment, you can't access SPL token, and you can't do calls from Solidity to Rust contracts, vice versa. So that's definitely very important. That's the thing we'll be working on next. Now that we have our own compiler, we can extend the language any way we see fit. So what feature is missing in Solidity? What can we add? There's lots of data structures which are missing. You don't have trees. You don't have arrays which you can grow, push or pop memory arrays. There's lots of things that could be added to Solidity. So as long as it's sensible, I just don't see any reason why it shouldn't be added. We've got more processing power on Solana. So yes, we would like to work on that. So I just wanted to talk about it briefly. We have a lot of documentation, mainly about the language, which kind of mostly is the same as the Ethereum Solidity compiler. We have a Discord channel, and please try it out. Let us know what you think. That's it. Are there any questions?
Any questions? Okay.
So you didn't speak a lot about data storage. For example, on Ethereum, you have mappings that can hold an unlimited amount of data. And
yes.
on Solana, you have accounts that have like this 10 megabytes limit. So how do you deal with this?
Yeah. So like you say, you have this key value store on Ethereum, which doesn't exist on Solana. So this is all handled transparently. If you have just fixed width fields that just become fixed, like the Flipper example, that's just a fixed amount of count data you need. If you have a mapping, for example, then you can add and remove elements. In that case, there's a mini heap which can do malloc and free on the account data. So that's all handled transparently. There's no key value store anymore. It's just the account data, which just the usage grows as is needed.
But what happens when the 10 megabytes limit is reached? Because on mapping, it's just unlimited. You can have like a mapping that holds more than 10 megabytes of data.
But if you try to store 10 megabytes of data on Ethereum, that's going to cost you a lot.
Yeah, but there is multiple users that are storing on the state, so it's not all the same user storing data there.
Yeah, so at the moment you are limited for one Solidity contract is one Solana account. So you are limited by that, yes. Yes. There might be a way of splitting that if necessary. Yeah, this is true. This is a limitation. Sure, we can work it out.
Probably have time for one more question if anyone's got one. Okay, cool, awesome. Thank you so much, Sean.
Thank you.
We are going to bring up the next panelist pretty quickly. Yeah, round of applause for Sean.